Hi, my name is Andrew. Today I'm going to be talking about dynamic programming and its real-life applications. For those of you who are not familiar with computer science, you may have asked yourself, what is dynamic programming? Is it even relevant to my life? As a matter of fact, it's actually very relevant to all of our lives, but to understand why it's so important to us, we have to first understand what it is. Dynamic programming is an algorithmic technique for solving problems. And an algorithm is a finite series of steps that help solve a problem. You may have heard the term algorithm used in some fancy context about a genius using an algorithm to do something highly complex, usually in programming. However, the truth is you may have followed some algorithms hundreds or thousands of times. One of the most obvious examples of an algorithm is a recipe. It's a finite list of instructions used to perform a task. For example, if you were to follow the algorithm to create brownies from a box mix, you would follow the 3 to 5 step process written on the back of the box. That is all about an algorithm. Pretty simple, right? Now that you have a clearer picture of what an algorithm is, let's dive right into what dynamic programming is. As I mentioned, dynamic programming is an algorithmic technique, but it's specifically designed for solving an optimization problem by breaking it down into simpler subproblems and utilizing the fact that the optimal solution to the overall problem depends upon the optimal solution to its subproblems. To put it simply, dynamic programming is suited for solving problems where the same work is being repeated over and over. Dynamic programming does not work for every problem. To determine whether we can optimize a problem using dynamic programming, you can look at two formal criteria of dynamic programming problems. First, a problem must have overlapping subproblems for dynamic programming. Subproblems are smaller versions of the original problem, and any problem has overlapping subproblems if finding its solution involves solving the same subproblem multiple times. Let's take the Fibonacci numbers as an example. To find the fifth Fibonacci number, we need to break it down into the following subproblems. If you look at the Fibonacci tree here, we have the overlapping subproblem pattern as the first Fibonacci number has been evaluated 5 times and the second Fibonacci number has been evaluated 3 times. Therefore, it's fair enough to say that Fibonacci numbers have overlapping subproblems. Second, a problem must also have a optimal substructure property. Any problem has optimal substructure property if its overall optimal solution can be constructed from the optimal solutions of its subproblems. If you look at the Fibonacci tree again, the fifth Fibonacci number is a product of the third and fourth Fibonacci numbers. This clearly shows that a problem of size n has been reduced to subproblems of size n-1 and n-2. Therefore, the Fibonacci numbers have optimal substructure property. If a problem meets the two formal criteria for dynamic programming, it's time to solve the problem. Though there are two methods that dynamic programming offers to solve a problem, a method called the top-down with memoization is how many tech giants are using dynamic programming. In this approach, we try to solve the bigger problem by recursively finding the solution to smaller subproblems. Because understanding this concept requires some experience with computer science, I'm going to replace the formal definition of this method with a simpler example. Imagine you're stuck in traffic. You can take many different routes from your apartment to your office or your school. Let's say you encounter many intersections on your way. At each intersection, you can take either a left, go straight, or turn right. Each intersection has a different amount of wait times depending on the traffic in that region. Now you have to optimize your route such that there is a minimum overall delay. Dynamic programming reduces the number of computations by moving systematically from one end to the other, building the best solution as it goes. The way it solves the problem is by moving backward from the office or school to your apartment. If you are in any intersection with no further intersections to go, you have no decision to make and simply incur the delay corresponding to that intersection. In the next intersection, you only have to decide the best possible route until the next intersection because you have already found out the best way to get from the last intersection to your destination. This way, you're not recomputing anything. You continue the same approach until you reach the apartment. This is how the top-down method works. This optimization reduces time complexities from exponential to polynomial for many problems. Time complexity refers to the computational complexity that describes the amount of computer time it takes to run an algorithm. So the fact that dynamic programming reduces the time complexity by much is why a lot of tech giants find dynamic programming so appealing. In fact, we can find the applications of dynamic programming in our everyday life. Let's take COVID as an example. Ever since coronavirus began to penetrate through every aspect of our lives, almost every country has suffered from the scarcity of testing kits to accurately track the new coronavirus. To effectively help deal with the scarcity, a lot of experts advocate the group pool testing method for coronavirus screening using dynamic programming. As you can see here, experts identified the subproblems in this sample, divided them into multiple groups, and applied the same algorithms to find out who has contracted the coronavirus. This new model with dynamic programming has allowed many countries to minimize the total number of test kits and the number of stages. That reduced number of test kits signifies the optimal use of resources, while the number of stages reduces the time required to identify the infected person. So it's fair to say that dynamic programming has helped all of us tremendously in the collective effort of bringing the normal back into our lives. In addition to that, dynamic programming is also used in a variety of ways. Let's take Google Maps as an example, as it seems really relevant to our lives. Google Maps was built upon the basis of the algorithms for the traveling algorithms for the traveling salesman problem, that is to find the shortest possible route that visits every city exactly once and returns to the starting point. The traveling salesman problem can be solved through dynamic programming with the time complexity being polynomial. That means dynamic programming has improved the quality of our lives tremendously with Google Maps that dynamic programming enables and allowed us to save more time. My presentation has only touched on the tip of the iceberg because I tried to keep it keep it simple and easy to understand for everyone, assuming no prior experience with computer science. And there's a lot more for you to explore about dynamic programming. I hope my presentation ignited your interest in computer science and dynamic programming, as computer science and dynamic programming are now an important aspect of our lives, and they affect and influence our lives in so many ways. Thank you.